Hello Year 7s. This video we are going to start looking at the idea of data representation in technology, and very specifically we're going to start looking at binary. So I'm going to start with a couple of questions. First of all, what is this? Most of you have probably said the number 0. What's this? Again, most of you have probably said the number 1. Here's another question. What's this? Now, some of you might have said it looks a bit like a number 3, but I want to ask you a different question, or want to point out something to you. The first two numbers, 1 and 0, are in fact just symbols that we have decided through history would represent the numbers 1 and 0. There is nothing about those symbols themselves, that stick and that oval, if we want to call them that, that's intrinsically mean 1 and 0. It's only that we as humans who use that particular numbering system have decided that that's what they represent. The squiggle that's on your screen right now could also have represented 1 or 0, or in fact anything else. It is about how we as humans decide what the context or what the reason for something is, how we give it a meaning. And that's very important as we delve into this topic of data representation in technology. So let's go on to something else. If I put this on the screen, what does this represent? So again, some of you will say 101, and based on our normal numbering system, that's a very fair assumption. It could also represent lol, and some of you might know what that means. It is a little bit old now, I get it. But others might have said binary, because maybe you heard what I said at the beginning of the video, or you know a little bit about binary already. Again, there is nothing about those particular symbols right now that tell us 100% what they represent. For most of us, we would go 101 because we're used to the decimal numbering system, and that looks correct. If, however, I add this little 10 down here, that is absolutely now telling me that this is a base 10 or a decimal number, and I can now interpret those symbols 101 as the number 101. This little symbol here is given the context that we need to understand what those symbols represent. Let's have a look at another option. Sorry, I apologize. Let's look at how that works. So again, this should be revision for you because you have done plenty of place value in your primary school years. So we now know that this is supposed to be a base 10 value. So if we look at the first place value, that represents our units or our ones. The second one represents our tens, and the third one represents our hundreds. And knowing that, we can say, well, we've got 1, 1, no tens, and 1, 100 as we go through those. And of course, we can then add those up and we get that number 101 in decimal. Let's have a look at another one quickly. Here we have 191, the same thing. We've got a 1 in the units. We've got a 9 in the tens, which gives us 90. And of course, we've got a single in the 100. So that's again 100. We add those up and we get 191. So again, in decimal, the numbering system that we use on a daily basis, we have 10 possible values that you can put in each of those place value positions. 1, 2, 3, 4, 5, 6, 7, 8, 9, and the 0. So again, that should be really revision for you because decimal is the numbering system you've been using your whole life. Let's go back to that 101 that we saw before, but this time, instead of the little 10 down the bottom indicating that it is a decimal number, let me give you this. So that little 2 tells me it is a base 2 number, or in this case, we call that binary. Let's look at place values for binary. Just like with our decimals, we start with our first column, our least significant value, and that's still going to be our units. But instead of going to the second column being tens, we're now going to go to a place value of 2s. Then we go to a place value of 4. It is doubling each time. So from 1s to 2s to 4s. If we went further, it would be 8s, 16s, 32s, 64s, 128s, and so on. And you could double it each time to get a further place value. So how do we read that? Well, the same process as when we were reading decimal, but with just different place value columns. So the first one is still a 1 in the ones or the units column, so that is still a 1. We've got nothing in the 2's column, so that is still a 0. And we've got a 1 in the 4's column, so that's a 4. We do exactly the same thing. We add them up, but now we get a value of 5. So 101 in binary is actually equivalent to the value 5 in decimal. So it's just about the place value positions. Let's have a look at another one. 1 in the 1s, 9 in the 2s, and 1 in the 4s. Now, some of you might have already picked up there is a big mistake here. We are doing a binary number, or looking at a binary number. We can't have a 9 in that 2's column because the only symbols available to us in binary are 0 and 1. It's got 2 values. That's what binary means. Bin means 2. So we can either put a 0 in a column or a 1 in the column. We can't have those other numbers. So let's look at this in a little bit broader context. Here I have the place values 1, 2, 4, 8, 16, 32, 64, and 128. Okay, let's put some binary in. So how would I work out what this value in decimal was? Just like we saw with the smaller numbers, we just go through it step by step. I have a 1 in the 1s, a 1 in the 2s, nothing in the 4s, 1 in the 8s, 1 in the 16s, nothing in the 32s, nothing in the 64s, and a 1 in the 28s. So we can see here that we're going to add those numbers up and we get the value of 155. So 1001111 in binary is the same as 155 in decimal. Let's have a look at another one. Here I have some more binary. Let's do exactly the same thing. Look at the place values. If I have a 0, then I'll have nothing. If I have a 1, then I'll have that place value. So if I was to go through them all, this is what I get. Nothing in the 128s, 64, a 32, a nothing, a nothing, a nothing, a 2, and a nothing. Let's add those up, and we get the value 98. So again, 0110010 is the value 98 in binary. Let's have a look at one more. 00111100. I'm going to give you a moment to go through and do that one yourself. If you need to, you can pause the video, and when you're ready, come back and see if you've got it correct. So hopefully you pressed play again on the video. That's why you're here now. So if we look at those, here is our equation. So nothing, nothing, 32, 16, 8, 4, nothing, nothing. So we're going to get a final value of 60. Let's look at one more. This is a special number. Here we have all zeros. So without even doing any math, I should be able to work this one out. But if we need to see it properly, they're all zeros. So of course, the final decimal equivalent will be 0. So if we have all zeros, then it's of course going to be 0. What about this situation? If we have all ones, a 1, 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 a 1. Again, we do the math. So we've got 128, 64, 32, 16, 8, 4, 2, 1. And of course, I can add that up and I will get an answer, but there's a quick way of knowing this one. And I'll come back to that in just a moment. But hopefully when you add this up, you've got the same answer of 255. Now, the quick way, of course, is what would be the next place value after this? So if in binary, if I was going to go up one more, I would have to get one more place value. I'd have a 1 in that column and then zeros all the way down here. So the next number, of course, it would be 256. One more than the biggest number I can get with all of these ones. So that would be the quickest way to know the next number up, or what is the maximum I can get with the columns that I have here. Just a little trick. If that's made sense to you, excellent. If it hasn't, again, just go through the place values and you'll be able to work them out. Now, here's some questions or some terms, that you will need to know. First of all, when we have this, it is a single bit of binary. A single 1 or a single 0 is a bit of binary, a term that you need to know, a bit of binary. It can have a value of 1 or 0, as I've said. When we have 8 bits of binary, we call this a byte, B-Y-T-E. So 8 individual bits make up a byte. Now this is important because in most of our classwork at least, I'll always expect binary to be presented in byte form. So you have to add values to it sometimes to make it into a byte. And a byte, as we saw earlier, can have a value from 0 if all the bits are 0, up to 255 if all the bits are a 1. So for example, here we have something different. This is 1111. Now this is not a term that you necessarily have to know, but I think it's kind of a bit fun, to be honest. So if you have 4 individual bits of binary, so it's not a whole byte, but there are 4 of them, it does also have a special name. It can have the value from 0 to 15 if we look at those place values. And that special name for this one, which I think is just a bit of fun, is a nibble. So again, not a term you have to remember, but I do think that's kind of funny. But you must be able to interpret or know what a bit of binary is and what a byte. So a bit is each single 1 or 0, and a byte is 8 bits of binary. But just for fun, you can also sometimes have a nibble. And that's going to end this particular video. So you should be able to convert from binary into a decimal number. And we'll follow up with another video, a shorter one than this one, on how to convert from a decimal number into a binary.